again, when you're talking about graphing tangents, what changes with a tangent graph is, I want to show you guys again via, using the unit circle about where the values come from. And I just use them again on the quadrantals. 1, 0, 0, 1, negative 1, 0, and 0, negative 1. So when we're looking at values of tangent, remember your tangents are going to be the ordered pairs y over x. Tangent of theta is always y over x, just thinking about it in terms of ordered pairs. So as we go through this, at 0, it'd be 0 over 1. So tangent at 0 is 0. You okay with that?
Yeah.
If I go up to 90 degrees, pi over 2, it's 1 over 0. Can you divide by 0?
No.
So what do you write it as? Undefined. So then I know that a tangent at pi over 2 is undefined. Tangent at pi then is, again, 0, because it's negative, or it's 0 divided by negative 1. And then lastly, back at tangent of 3 pi over 2, it's back to undefined, because you can't divide by 0. You guys vaguely remember that? We also have the value of tangent equal to 1 at some angle. What angle is that, remember? Where is x and y the same? At your 45s, remember that? At pi over 4, it was root 2 over 2, root 2 over 2. So the tangent at pi over 4 was 1. What about at 3 pi over 4?
2, 1.
Negative 1.
Thank you. Negative 1. And then obviously, these two are be the same values because the sign's the same and so on. Okay? So what happens with the tangent function, you'll notice that if it's between, if you're between 3 pi over 2 and pi over 2, all those values exist except for on the vertical axis. You get the asymptote. Same thing on the other side. It repeats itself coming back around here. Tangent's period is not a full 2 pi. Tangent's period is defined within just pi because you get that breakpoint on the vertical. Okay? So when you're graphing tangent, it looks a little bit different. This a value technically isn't called amplitude because tangent, if you remember, is swooping up. The amplitude is the highest peak, whereas tangent isn't that. Tangent does this. This a value is going to be these point change direction style things. So I still kind of call it like an amplitude-ish, but once you plot it a couple times, you'll realize where they're going. So we call it an amp-ish. B helps with period again. But our period here is going to be pi over b. So let's look at real basic y equals tangent of x, where a and b are both 1, just to start with that. Now, one thing that tangent does is tangent's always going to go through the origin. It's going to always go through 0, 0. Okay? If you think about the way that it works, it does that. And it starts at 0 and it goes up to this one and it comes back to the other side. And then it oscillates to the other one. It continues. So what we do is this. We draw our axis in, and we know tangent's going to go through the origin. what I need to figure out is how to place my period. Since you're dividing by 0, you're going to get vertical asymptotes. Remember that from polynomials or polynomials? Anytime you have 0 in the denominator, you have a vertical asymptote. Same thing happens here with trig. So we have 2 vertical asymptotes, and these vertical asymptotes are apart whatever your period is. Okay? So there can be an equidistant amount to one side of the origin as there is to the other. So if the period is pi, half of it's on one side, and the other half is on the other side. Therefore, to the right of 0 is how much pi? Pi over 2, and then the other side is negative pi over 2. So this is what happens with your tangents. You get a pi over 2 negative, and a pi over 2 here. Your asymptotes for an original tangent graph will always be placed at pi over 2b. Whatever your b value is, be pi over 2b for where your asymptotes will be placed for the original graph. Okay. So now what happens is you've got those breakpoints, and that's where the pi over 4 comes into play. Because halfway between 0 and pi over 2 is pi over 4 and negative pi over 4 on the other side. And that's where that a value occurs, where those change, where tangent becomes 1. Okay? It becomes 1 at positive pi over 4, and becomes negative 1 at negative pi over 4. So when you're graphing tangent, you generally wind up with just 3 points. Hug your asymptote, come up through the origin, and hug the asymptote. And that's what tangent graphs look like. And then they just repeat themselves each pi period on either side. Okay. You guys vaguely remember doing that last year?
Yeah.
So again, your asymptotes are at pi over 2b. Okay. Pi over 2b is where you're going to get your asymptotes to start. Shall we do an example with that a's and b's are not 1?
Yes.
Yay!
Wait, Mr. Murphy, how did you get this equation again?
The pi over 4? What's halfway between 0 and pi over 2? Is that what you're talking about?
Yeah, why do you divide it by 2? Like, why do you divide it by 2?
What's that?
Like, I don't get the how do you get the pi over 4?
Oh, how do I get this pi over 2 here?
No, pi over 4.
Oh, what's halfway between 0 and pi over 2?
Pi over 4.
That's where I get it from. Because in the graph, just one second, Ken. If you think about the way that tangent works, at pi over 4 and negative pi over 4, it's equal to 1 or negative 1. Because your ordered pairs are root 2 over 2 and root 2 over 2 and then negative root 2 over 2. So that's how you get your positive and your negative values. That's where the a value occurs. Okay. It'll occur at halfway through the origin to the period on both sides. So,
Do you only want to scrap the period?
I know the book says 2, and you know what? I totally forgot to ask Mr. Fontana if he wants to go 2 periods or not.
Straight minutes is
Really?
free. Like one negative, or like one to the left and one to the right.
For tangents? I'll ask him so I think the book says do 2, but I think today, when we do shift ones, we'll probably do 2, but for today, just to get our minds back to what it looks like, we'll be okay with 1. But thanks for reminding me, I gotta ask him.
Make your own rules.
I think I've seen that on a bumper sticker.
I don't want them. Yeah, yesterday.
What has it been, Mark? I wouldn't do it, but I wouldn't.
So walk right in.
Yeah.
How was he gonna notice it? Yeah.
Put a sign to look at the window. We'll get over it. Let's do one with the graph, with a and a b value. So let's see. Y equals what I have down here. 2 tangent of 1/2 x. Sometimes you'll see it written as 1/2 x. Sometimes you'll see it written as x over 2. Means the same thing. You walked right by it, didn't even see it.
I told you that.
Seriously. Mr. Fontana, what's up? I have let you know, you didn't even notice it. Yes, I am.
He's having a class right now.
No, it's just.
Hey, how many periods of on trigger are you gonna go? 2 or 3 for pre-calc?
1.
Hi, Anna.
Yeah. 2? Okay. All right. The answer is 2.
Wow, really?
I
didn't hear you. I had no idea. 2? 2 or 3 for pre-calc? Okay. He's like, good thing I don't have girls at home.
What?
Are you going to the game tonight?
We're gonna hope to. My kids have been getting over a cold this past week, and I'm
Are your
starting to
kids
come down.
Sycamore?
No, they go to Jefferson.
I didn't know that.
You go to Jefferson? I live by Jefferson.
So do I. It's crazy.
Wow.
Anyway,
We're like
so
I live by Jefferson.
No, he's my uncle.
why did I choose this class? Anyway, so we figure out what our period is going to be. We know that it's a non-shifted tangent graph. So we just know it's going to go through the origin. If our period, guys, if our period's going to be at 2 pi. Yes, ma'am.
2 pi over b,
2 pi over b, yeah.
d or 2 pi over 2.
It's pi, or not to be. It's going to be pi over, sorry, I had to. It's going to be pi over b. That's where we're getting pi divided by half using 2 pi. And then we'll cut it in half to split up the asymptotes.
Drop your marker. What if you really didn't drop something and you look
So we know that the period's going to be at 2 pi. We know the period's going to be at 2 pi. So that means half of it will be to the right of where we go through the origin. The other half will be on the other side. That's where we get our asymptotes at pi and negative pi. That means the period between the two asymptotes is where it comes from. Okay?
How do you, okay. How do you get
We know that the period is 2 pi, which
Yeah.
means your asymptotes
Oh.
are going to be at whatever your period is divided by 2 on either side of the origin when you start. When we go to shift everything, we still do the same idea, and then we just pop them through by adding values to it or subtract.
Right.
What should I send this down?
Huh? I already wrote all this down.
He just wrote.
Yeah.
I just wrote.
What's halfway between 0 and pi?
Half pi over 2.
So you have pi over 2 and negative pi over 2. Our a value is going to be at 2. So that's where these change direction. Since our a value is positive, it's going to be increasing going from left to right. If it was negative, it would be decreasing from left to right. So it's going to be at pi over 2 and negative 2, 0, pi over 2 and 2. And there's your graph. Now, like Mr. Fontana just said, we should be doing 2 periods of this. When we have the tangent graph, I guess we just go to the right one. It might be a little bit easier to have to deal with the negative ones. It doesn't matter really. If I go to add another period, if one side's going to be at pi, come across here, I'd have to add what to get to the other asymptote? I'd have to add 2 pi to that, so it would be at
3 pi.
3 pi, and then where it would cross through the middle would be at 2 pi. So if that's at 2 pi, that's at 3 pi, this would be, would that be 5 pi over 2? 2.5 pi. This would be at 3 pi over 2. Yeah, I guess it's not that big a deal to do that. And that's what it would look like. Is that okay?
Yep.
No, what do you mean no? You vaguely don't remember that? Yes, sir.
For sine and cosine, we're gonna do 2 periods as well, right?
Yeah, we'll start doing 2 periods then.
Like right side and left side, or so right, positive.
You know,
like negative, positive.
we should probably do 1 negative, 1 positive, really.
I don't think it matters.
If there's gonna be one on the test, then yes.
If it's
Some people aren't that smart.
Oh yeah, I guess you should probably figure that out.
You'll have to ask me.
Because I think does the book do? I think the book might do 1 negative, 1 positive. You know what? Some of Fontana's students stopped and tried to get in here because they saw Mr. Fontana pointed the arrow here and started looking here and realized I wasn't him.
That's inspiring.
Yeah, I got something to look forward to, right? It's like I can only be as cool as him.
I think it's cool.
Yeah, 2 full periods. It doesn't really say which way to go. It just says 2 full periods. So I guess if we just go to the right, it might be all right. One last one, and then I'll let you guys give you guys some problems here.
I'm so mad today.
Take a minute and graph 2 periods of that, please. Well, let's go through it then. In this one here, you've got A is 1, B is 4 pi. So then that means your period would be pi over 4 pi.
Oh my gosh, I was right.
So it's pi over 4 pi. I think you wrote down 2.
Pi, wouldn't it be 2?
That's what I was going to say, because I think you had it. So now your period is going to be
Yeah.
1/4.
I thought the periods would be
Half what?
Negative 1.
2 pi over 4.
That sine and cosine is the periods, or 2 pi. Tangent is pi over. So now when you go to get your asymptotes is going to be, excuse me,
Don't die.
your asymptotes are placed at half of whatever your period is. It's half of whatever your period is, because if your period is from here to here is going to be 1/4, this side would have to be at 1/8. This one would have to be at negative 1/8. And halfway between here and here would be 1/16, negative 1/16. And then your A value is 1, so it's just going to be at 1 and negative 1, so it's just. And that gives you your three ordered pairs that you have to worry about. Increasing from left to right. And remember, it's increasing going from left to right because the value of A is positive. If A was negative, it would just be going the other direction. Okay? So I have a handful of sine, cosine, and tangent graphs mixed together. Yo!
Are you doing the second period? So no.
Mine's right.
Just add-
Mine is
add the next
I
two.
didn't even do one.
So if you gotta go add the next asymptote, if you're continuing on this way,
You have 1/4, right?
extra.
this next distance has to be 1/4. Now, what's nice about doing it this way, if you're going to add 1/4 to the 8th, add it as 2/8. See what I'm doing there? I'm just quickly adding it to the common denominator, because this distance from here to here should still be 1/4. So add 1/4 to an 8th is the same thing as adding 2/8. So this would be at 3/8. Okay, so between 1/8 and 3/8 is still a quarter. And then you'll be able to get your halfway point, which would be at 2/8, which is has to be that 1/4 again. And go from there.
Cold-blooded, they do, have no soul. Will not get. Just don't touch
And what it is here, these are just the problems themselves. No graphs or anything on here. It's up to you guys to figure out your spacing and all that other junk to go for it. Go ahead and practice trying to do two periods on these things, okay? 2 full periods. And then we'll see how we did on Monday. We'll talk about shifting sine, cosine, tangent Monday. Tuesday we'll start talking about the inverse trig functions and their shifts as well. We'll probably be graphing Monday, Tuesday, Wednesday, maybe even to Thursday a little bit. Then after that it jumps into solving equations again. So we got plenty of time. I don't know. We'll play by ear. We might just do one on graphing.